Assalamualaikum warahmatullahi wabarakatuh. Welcome to my presentation. My name is Sheffield Tivan. I'm going to do presenting about my thoughts about making the 3D models and simulation of a 6-toy OV arm robot. So I'm just gonna check the episode real quick. This. So the one that I'm gonna really make or replace or making the 3D model of this is the 60 OV POF of the DIY Yaskawa arm robot like this. So this robot is has several links and joints. There are about 6 joint and links. First one is about around here. So action. This is the first one. Will be D1. This is second, third, fourth, and fifth and sixth. Every links have their own joint. One over here is the joint is over here, the other is over here, and so on. As you can see, the model robots have their several position and angle for their own links and joint. First one is upright. Second one is a little bit to the left, angle to the left. And the other one is angle to the other side, to the right side. And the one is flat 90 degree. And the other two will be like on here, or it's like you can say 90 degrees like that, parallel. Now, now that we know about the all of the requirement to make one to replicate the 3D models, we're going to use a Cygwin and OpenGL for making these 3D models. Let's go back to the thing again. Now they already made the program and we are in the Cygwin. When they have the models is on the planar OBJ. So just let's go to G 6 And here we have two main programs. The first one is the planar.c, where I define all of my links and angle for this theta. But this one is actually G, and it will use for this doing to call the data log. But for now, we're not really need this, but we're going to the main program. This one is the main program that will define all of the library that you use, all of the definition for the offset, links, and the theta. This is the angle. Also, in the before the planar.c, the other one that I told you about the main program before have the length and definition for the length and the value of the key, which actually the angle we're going here to see. Like so. And then this is the definition for a color. This is definition for the cylinder that we will make. We are using a cylinder and box model. The cylinder model is settings like so. And same with the box. This is display, setting display for the floor. All of them is actually using OpenGL library. Well, all of them for the 3D models and the landscape models and something. And other is just the metrics for mathematic calculation. This one is the display robot, which actually giving the 3D model from the basic cylinder and box before we actually have seen. Now we are implemented into the matrix. First one is the base is drawn like this. The next one is the joint, which will be rotated in the z-axis, XYZ, z-axis. The next one is joint 2 will be rotated on the y-axis, and with the position translate like this, and every link will be rotate or have a pivot point on the end of the other link, like so. the idea to making it looks like the work of servo much more than just rotating on whatever before these points. Looks much more realistic too. After that, after we're done with the position and the rotate pivot point angle, we're going to make the control keyboard to rotate manually. In this case, we're still doing it manually to ensure the movement or the pivot point that we are on is actually the right one. So in this case, the theta one will be controlled by button number 1, 2, 3, okay, and so on. All of them is a keyboard stroke, keyboard key cap, key point. If we press the button, it will rotate this theta one on the link one, join one into rotate 5 degrees. After that, there is an exit button. Then there is settings. Setting is making it the starting position of the robot much more likely. Like we see here, it's going to start from upright and then have the angle like that. If we don't giving this, they will just gonna straight up or just doing like this. Now that we already have seen already, let's go start the program. First thing first, we need to make the program because I already compiled the program, and then we can run the program, and this is the result. As we can see, when I press 1, they will rotate on the z-axis, and I press 7, we're going to run, and this is the first link. Second link, it's over here. If I press 2, they will going down. Just make it easier. This. And the third link, this one. And fourth link is this one. So if I want to grab things like that, I can use this one and this one to control the forward mechanic. The other like this is for rotation. Last one is for the small one on the middle C. So rotate like this. So if I want to make it forward, I can make it down like this and like this. So maybe pick up something on the bottom like this. I think that's it. Presentation about this 3D models and simulation of the 60OF arm robot. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.